Hello guys, am I audible? There is one thing that I messed up here is okay. Okay, nice. If I'm audible and I'm also visible. Yeah, so in today's PCD, we will discuss the first four problems of the Codeforces round. Um, we will discuss the first four problems of the Div 2. So that is basically the first two problems of Div 1. And yeah, so let's first of all talk about TLE eliminators because they are the ones who are conducting these PCDs. So just in case if some of you don't really know, TLE Eliminators is the one who is conducting these PCDs and they have a CP31 sheet as well. These are the two free resources they have been providing. Along with it, TLE has some paid content as well. They have courses distributed in four levels. So it's basically like the beginner friendly content would be taught in the first level, and then the a little advanced topics would be in the level 2, then more advanced topics in level 3, then more advanced topics in level 4. So you can check out these courses. And one of the best things that I do like about the course of TL Eliminators is that you get an online community. Like you can, when once you buy the course, you can join to the Discord server, and there you will find out a lot of people who have also bought the course, the ones who are gonna be somewhere around your same level. So you can make friends of your level if you buy the course. Like you don't really need to buy the course for this thing, but this is one of the best, um, like one of the most underrated things that you get there. And nextly, you obviously have the content, though content is also available online, but in TLE also you will get some good content. So you will not have to check out the content at different websites, and you will get some curated problems. This is actually a good point. Like this is also a very important thing because if you are just doing some random problems, then in that case, you will have to do more problems for covering all the standard topics and standard problems. Nextly, you have the doubt support. This is the unique selling point of TLE courses, that you will get instant doubt support. Like TLE Eliminators has a lot of mentors who would be available for solving your doubts. And uh, yeah, so I think that were the most important points for the course. And yeah, you can check it out. Initially, like earlier, TLE Eliminators used to have batches, like a 3 month long batch where people can join and then they will have videos for the next 3 months. But now TLE Eliminators has started self-paced course also. So in this, you can buy a course and you would be given all the recorded content of the um like of all the topics that are to be covered. Like you can check out all the topics that are gonna be covered in each level by going like this. Go to the topic page, and then I think it would be available somewhere here. Um, Prerequisites, and then yeah, all the modules, all the topics that would be covered in the course. So this is one thing you can check out. And yeah, so all in a nutshell, this was just to make sure that the audience which is coming up on this channel knows that TL Eliminators has this content also, so that they can check it out in future. If they are willing to buy a course, then they can consider TL Eliminators as well. And now let's start the PCT. So the very first problem of the Div2 contest says that we are being given four integers n, m, p, and q, which um, yeah, these will be four variables, and we have to determine whether there exists an integer array from a1 to an, where the elements can be anything. They can be positive, zero, or negative as per our choice. Uh, we have to determine if there exists an array which these two conditions. The sum of all of the elements of the array should be equal to m, and the sum of every p consecutive elements should be equal to q. So if you pick up any subarray of size p, then the sum of all the elements of that subarray must be equal to q. Yeah, so these are the two conditions that must hold for the array. And we don't really have to return the array. We don't have to print the array which satisfies the condition. We just have to tell whether it is possible or not. So I hope the problem statement is clear. The problem is quite straightforward. I solved zero problem. Was the contest hard? I think like first problem is not difficult. Anyways, since you could not solve it, I will go a little slow for the first problem. Otherwise, I was planning to go a little fast. How many problems you guys solved today? A was easy, then B. I missed a bit C. Yeah, C was a little messy, I think. Okay, so the A problem here says that we would be given four variables n, m, p, and q. We have to tell if there is like if we can construct an array A having n elements such that the sum of all of the elements of the array must be equal to m, and if you pick up any subarray of size p in the array, then the sum of that should be equal to q. So sum of um, p consecutive, I don't know why is it like this, p consecutive elements should be equal to q. I hope the second point is also clear. Like if you have an array like this and you pick up any subarray of p elements, basically subarray of p size, then the sum of all of these elements in this subarray should be equal to q. And that thing should be valid for all the other subarrays also. And here is one tip for you. Like if you ever see something like this in any problem where sum of p consecutive elements should be equal to q for all of the p consecutive elements that you can choose, then in that case your array would look something like this: a1, a2, a3, and so on till ap. After that, since the sum of these p elements and the sum of these p elements from a2 to ap plus 1 should be equal, and all of these are actually common in both of these subarrays, so you can actually prove that a1 must be equal to a of p plus 1, right? So whenever you have this kind of a situation, um, there is a very common conclusion from here that a of I should be equal to a of I plus p, or a of I plus b should be equal to a of I. You can say it in any way. This thing should be valid for all I such that I plus b is like it should be true for all I such that I is less than n minus p and greater than equal to 0. So guys, is it making sense till now? In case if you did not know about this thing, then you can know about it now. And I don't think it is difficult to grasp. Basically, the idea is that if you consider like two subarrays of size p such that there are uh, these p minus 1 elements common in both of these subarrays, and you know that the sum of this subarray and this subarray must be equal. So obviously this guy must be equal to this, right? Because like if you want to prove it mathematically, you can say it in this way. Sum of the first p elements should be equal to q, and the sum of the next p elements from a2 to a of p plus 1 should also be equal to q, since RHS is equal. So this thing and this thing should be equal, and the elements from a2 to a of p are common in both of them, so you can just cancel them out. So you would be left up with a1 equal to a of p plus 1, and this is how you can prove this thing everywhere. Okay, so in a nutshell, let's say if you had an array, like now let me take one example here for a better understanding now. Let's say if n is 10 and p is 4, and the first element you placed in the array is, let's say, a. I'm just or maybe let's call this thing as x. Let's say p is 3. So in the array, the first element I placed is, let's say, x. It can be any value. I'm just using a variable for now. The next guy is z. The next guy is, sorry, x, y, and z. Then you know that the fourth guy must be equal to x. The fifth guy must be equal to y. The next guy should be equal to z. Then x, then y, then z, then x. Right. And you know that the sum of any three consecutive elements must be equal to q. So x plus y plus z should be equal to q. And you know that the sum of all of the elements of the array should be equal to m. So it is basically 3x, sorry, not 3x, but 4x, since x is coming up 4 times here, plus 3y plus 3z should be equal to m. You will have like two conditions, two equations that you want to be true at the same time, right? That is, we just want to find out if there exists some values of x, y, and z such that both of these are true at the same time. So guys, are you with me till now? Why is the time in your time always 9:41 the 9th gen? I also don't know about this. On whenever I share my screen using the QuickTime player, it always shows this time. And it is not just specific to me. It happens in other people's videos also. When I look at someone else sharing a screen in the same way, I don't know if it is a glitch or if it is some hidden option that I have uh, that is turned on by default. TLE course Telegram में मिल गया क्या? Uh, yeah, but TLE course, like the one you're talking about on Telegram, will only have the content. And if you remember, at the time when I told you about the content, I said one more thing, that content is available online also. So if you only want content, then obviously you don't really need to buy the course. Oh, XYZ, then XYZ again. Okay, you did not understand this. Let me tell you again. So what I discussed earlier was, since we have a condition that the sum of any p consecutive elements should always be equal to q, it meant that if you talk about, like, let's say yours, you have an array, you want the sum of the first three elements and the next three, these three elements must be equal to q, right? Here, the sum of these three should be equal to q, and the sum of these three should also be equal to q. And you know that um, if both of these need to be equal to q, it means that the sum of these three and the sum of these three should be equal to q. Now, in this equation that you have for the sum of these three and these three, two of these are like common. These two are coming up in both of these ranges, right? So you can just ignore them, which means that the sum of this guy and this guy must be equal to each other. So if this guy, the first guy of the array, was having a value x, then the uh, fourth guy must also have the value x. And then the seventh guy must also have the value x. Then the 10th guy must also have the value x. I hope it is clear now. do you want to proceed? No, I don't want to proceed. In fact, I want to erase this. I can't. Okay. Is it clear now? Okay, got it. Great. Yeah. So now I just want to confirm, like, I just have to tell if it is possible to have some actual values of x, y, z such that both of the conditions are satisfied. So, see, I can rewrite this condition as you had a total of n elements, right? You know that the sum of the first p elements must be equal to q. Then the sum of next p elements should also be equal to q. Sum of the next p elements should also be equal to q. And then you have only one element left. So can I say that this thing is nothing but 3 into q, right? 3q plus x. This thing should be equal to m. है ना? And this value of x uh, that I have here is something I can decide myself. So I can create an array in which this x is equal to m minus 3q, right? I can decide the value of the first guy to be equal to m minus 3q, right? This 3 came by the logic of n by p, the number of times I will have pp consecutive uh, elements. I know their sum would definitely be equal to q. So I can just choose a value of x such that this thing is satisfied. Now, once I choose the value of x, I can choose some values of y and z such that this condition is also satisfied. So both of these conditions would be satisfied at the same time. Is it making sense? Let me take a simple dry run example also. So if let's say q was equal to 5 and m was equal to 15, or maybe let's say 18, let's say, right? I wanted to make sure that x plus y plus z is 5 and um, 4x plus 3y plus 3z is equal to 18 here. So what I can do is I can just say that first of all, I know that x plus y plus z is 5. So I can rewrite this thing as x plus 3 into x plus y plus z equal to 18. Now I can replace this x plus y plus z with 5. So I got x plus 15 equal to 18. From where I can just say that, hey, x must be equal to 3. Now, once I have decided a value of x, I can just put it here that, hey, x must be equal to 3. So y plus z must be equal to 2. And obviously, I can uh, pick up some values of y and z such that they sum up to 2. A very simple way can be just let y is 0 and z is 2. So you can definitely create an array where um, both of these conditions would be satisfied. Now, if you take this thing with the variables as we had taken earlier, x plus y plus z must be equal to q. And you will have 4x plus 3y plus 3z equal to m here. So you can always rewrite this thing as x plus um, 3 q, basically 3 into x plus y plus z, that will come out to be q, which should be equal to m. And you will get a value for x that you should put. And once you decide a value of x, you can just decide values of y and z accordingly to get some values of x, y, z such that both of these conditions would be satisfied, right? So it seems like we can always um, decide some values of these elements for the array, and we will be able to satisfy both of these conditions, right? And for like, always remember one thing: for the first three problems on Codeforces, right after reading the problem, if you just come on to the test cases, most likely you will get some very big hints, or all the edge cases for these problems would be covered in the sample test cases. At least for the A and B problem, most of the times the edge cases are being covered. So you can see that there are some cases for which we are having the answer no, right? So you can try to figure out the case where we can have no, and from there on you can try to think that um, in which cases we might not be able to satisfy both of these conditions. You know, so if you look at the sample test case like 10, 7, 5, and 2, 10, 7, 5, and 2, what is happening here is you will have the elements as A1, A2, A3, A4, A5. A6 would be equal to A1, so let's call it as A1, A2, A3, A4, A5, right? The two conditions you will form here are A1 plus A2 plus A3 plus A4 plus A5 should be equal to Q, that is equal to 2, and 2A1 plus 2A2 plus 2A3 plus 2A4 plus 2A5 should be equal to M, that is 7, right? So here, in this case, you cannot rewrite it as something like this time, because this equation is basically like this equation, you know. um it would be written it would be written as 2q equal to m this time, right? We are not having a free variable like the last time. The last time we were having a free variable x, but this time we are not having any free variable. And if you don't have a free variable, since you already know about the value of q and m through the problem, so either 2 into q is equal to m, this thing would be true or false. If this equation is already true, then your answer would be yes. You will be able to form some array. You know, otherwise you can never form an array. Like in this case, whatever values you decide for this sub array of size 5, the sum of all of these elements must be equal to 2, and the sum of these elements must also be equal to 2. So the total sum of the array should come out to be 4, but you want the total sum to be 7. So in this case, you will not be able to get your answer. So the conclusion here is, if n is divisible by p, then your answer is basically, you will have n by p blocks of size p, right? Each of these blocks will have the sum equal to q. So this thing must be equal to m. If it is equal, then your answer is yes. Otherwise, your answer is no. In the other case, if n is not divisible by p, then your answer is always yes. Otherwise, your answer is simply yes. In this case, answer might be yes or no, depending upon the case, like what happens here. So does it make sense? Not clear. It have you sent this message 6 minutes ago. So Priyanshu, can you please confirm which thing was not clear, and is it still unclear or is it clear now? You have done proof. Yes, maybe the proof was not required, but I don't know. Once more. Okay, let me do it once more then. I got TLE course, maybe 10 and 11. Guys, please don't talk about the illegitimate, illegitimate, illegitimate ways. Yeah, illegitimate ways of course. Basically, don't talk about pirated courses here. We can't allow it. Okay, so what I've discussed for this problem is, you were being given four variables n, m, p, and q. You had to tell if you can construct an array A of size n such that the sum of all of the elements is equal to m, and the sum of any p consecutive elements of the array would be equal to q. So from this constraint, I told you that whenever you see this constraint, you can always conclude that ai must be equal to a of I plus p. This thing must be true, otherwise you cannot have this constraint true. So if you're having that constraint true, Your array would look something like this. If let's say P was 3, then you will have 3 elements of your choice. Then those 3 elements will just keep on repeating. You know, and in total you will have an elements. So you have to make sure that you are choosing the values of x, y, and z such that these two conditions are true at the same time. The sum of x, y, and z should be equal to q, and the sum of the whole array should be equal to m. So for the part of talking about sum of the whole array being equal to m, you can say it in two ways. Either you can say 4x plus 3y plus 3z. Now, we have covered all the elements in this way. The sum of all of these must be equal to m. Or you can say 3 full blocks of PP size plus this one guy. The sum of this thing must be equal to m. So these 3 blocks, each one of them will have the sum q. So the total sum of these 3 blocks would be 3q plus this last free guy, that is x. So 3q plus x must be equal to m. If you have this, like, you can rewrite the condition in this way also, right? So you want both of these conditions to be true at the same time. So my idea was this q and m are fixed. So based on the values of m and q, you can decide a value of x. Like in some problems, let's say if n was 11 here, then you might even have a y here. And now your equation might actually look something like this, but it is not a problem. At the end of the day, you will have 2 variables or 3 variables, any number of variables. You just want their sum to be equal to m minus this stuff, right? These the m and this q would be given to you, and this multiplier here would be equal to n by p. So you can always just you can easily find out some um, values of x and y which will satisfy this equation. And since you would have decided the values of x and y which were satisfying this condition, now with the help of the other remaining free variable, like the variable whose value you have not decided yet, you can pick up its value in such a way that the sum of these three would be equal to q. So in a nutshell, if you are having at least one free variable here, at least one variable which is at least one variable which is not a part of the complete block, then your answer would always be yes. And other possibility is you might have a situation where n is divisible by p. In that scenario, you will have complete blocks, like a complete block of 5 size and then a complete block of 5 size. And you know that the sums of these blocks must be equal to q. So if you are keeping this first condition true of the sum of any 5 consecutive elements being equal to q, then the sum of the complete array must be equal to n by p into q, right? And you know that you must have the sum of the complete array being equal to m. You have to make sure that both of these constraints are true at the same time. So this is possible only if both of these values are equal. If n by p into q is equal to m, only then you can have both of these conditions true at the same time. So this is how we can reach to the conclusion that if n is divisible by p, then n by p into q, this thing must be equal to m. If it is, then the answer is yes. Otherwise, the answer is no. And in case if n is not divisible by p, then you can always have your answer yes. So guys, is it clear now? Once again? Okay, you called it 5 minutes away. Yeah, I also want to go to the next problem now. If I have submitted 0 times today but registered, my rating will go down. No. If you registered but you did not submit any time, then your rating will not be affected. You would not be considered as a participant. Yeah, now let's move on to the second problem. Problem B. The time is 11:46 right now. Oh, we have spent 30 minutes so far. That's tragic. Okay, so we have an array A of n elements. We can do the following operation any number of times in this array. where we have to choose an index I and we can multiply that value ai by -1. Our task is to determine whether it is possible to make the element at the index 1 as the median of the array after doing the operation above operation any number of times. And we can apply the operation on index 1 as well. Okay. And then they are telling what like the way they define the median. So if you have, I will tell you about how they define the median. And it is guaranteed to the, yeah, so all the absolute values of the elements of the array A would be distinct. Okay, so the problem A is, so the problem B is we would be given an integer array A of size n, where n can be as big as 2e5, I guess, no, 1e5, 10 raised to the power 5 here. Okay, and we are permitted to apply an operation on the array. There is an operation we are permitted to apply. And this operation, what we have to do is choose an index I and then set ai equal to minus of ai. Basically, multiply the element on the ith index by -1. You can apply this operation as many times as you want, including zero number of times. Our goal is to apply this operation to make sure that after all the operations that you have applied, the first guy of the array, let's say A1, should be the median of the array. Should be the median of the array. Now, how is a median of an array defined? Let's say you have an array A1, or let's say you have an array E1, 4, 5, something like this. Then for finding out the median of this array, you can sort this. So you can sort the array. So after sorting it, it will become something like 1, 2, 3, 4, 5. And if the number of elements in your array is odd, then the guy in the extreme middle would be the median. This is gonna be our median here. In case if the number of elements in the array were even, let's say you had an array like this after sorting, then the you will have two people in the middle. Both of these are the middle people. The left one, the left one would be considered as the median here. So in case if there are two middle people, then the one who is on the left would be the median, right? So this is how we define the median. And yep, that's it. That's the problem. Given an array, you can apply these operations as many times as you want. Our goal is to find out whether we can make the first guy of the array a median. And you are permitted to apply an operation on the first guy also. That is also permitted. Okay, so let me take an example. I think dry run would be better for this problem. Let's say you had an array like 1, 2, 3, 4, 5. You had an array 1, 2, 3, 4, 5. Then to make sure that 1 is the median, what you want is once the array would be sorted, 1 should come at the center, right? So you want to have half of these people greater than 1 and half of these people smaller than 1. And to make sure this thing happens, you can just keep two of the larger people as it is, and for the other people you can just multiply them with -1, right? So you can make the array look like this, so that 1 will become the median, right? This is how you could have solved this example test case. Let's consider this example test case now, the 4205, 420 minus 5. Okay, yeah, okay, yeah, it's fine. I was just confirming something right now. Yeah, so if you want to make this um if you want to convert it into an array so that 4 becomes the median, um, what we want is you should have 4 such that there is one smaller guy than 4 and two people should be larger than 4, right? And if you try to aim this, um, you see, there is only one guy who can become larger than 4. If you apply an operation on this guy, then it can become larger than 4. But for these people, they can never become larger than 4. So you will not be able to make sure that 4 becomes the median. Does it make sense? If you try to make sure that 4 becomes the median of this array after applying some operations on this array, um, you cannot make sure that there are two people who are greater than 4, right? Because for these two people, even if you apply operation on these people, they will still remain bigger than 4. As for this guy, you can apply an operation to make it 5, but you have only one guy which is larger than 4. So this is not going to work. But if you remember, we are permitted to apply operation on the first guy also. So if we apply the operation on the first guy, in that case, this guy will become a -4. And now we want this -4 to be the median. So if you want -4 to be the median, you want there should be two people greater than 4 and one guy smaller than 4. So there is only one guy which can become smaller than 4, that is this -5, if you don't apply operation on this guy. And there are only these two people who can, like, sorry, there are these three people who can be larger than 4. है ना? All these three can be larger than 4. Sorry, all these three can be larger than -4. So if you just keep them as it is, they're already larger than 4. And even if you apply operation on any of them, it doesn't really matter. They would be larger than 4 nevertheless. So this is how you can solve this example, right? So what we have learned right now in from these two example test cases is, first of all, if you have sufficiently, like if you have too many people who are larger than the current number, then you can just make sure that some of them are being multiplied with -1 so that they will become smaller than you. है ना? Is if their value is greater than you, um, when you multiply them with -1, they will definitely become smaller than you. Even if you had multiplied the current guy with -1, even in that case, they would be smaller than you. Right. So having more people who are larger than you is actually good, and that is being confirmed more here. Because for this guy 4, these two people were not really very handy for us. है ना? When you wanted to make these people larger than you could not make them larger. You could not make any of these larger than the current guy. Whereas the one who is having a bigger absolute value than 4 can become smaller or bigger than 4 as per your choice. Right? Do you guys see this? If you have a number which is having a bigger absolute value than the number on the first index, then you can decide whether this guy should be smaller than the number or larger than the current guy by deciding whether you will multiply this guy with -1. Whether you keep this 4 as 4 or you keep this as -4, it is still in your hands whether you keep it on the left or on the right. For the other people who are smaller than you, um, you like if you are having the positive value, then they will definitely be on the right hand side. Sorry, if you are having the positive value, then they will come on the left hand side of yours. If you have a negative value, then they will always come on the right hand side of yours. So in a nutshell, the idea is you want to find out find the number of elements that are having smaller absolute value than the absolute value of A1. Right. If we do this thing, we will know about the number of integers that we cannot control. Right. We can control whether all of them will come on the right or whether all of them will come on the left by deciding whether the current element would be positive or negative. But if you are having a positive value, then it means all of them will come on the left. You cannot make any of them come on the right, right? So if let's say you had an array of size 9 and there were 5 people who were smaller than A1, or let me just take an example test case from sample test cases. Example where we would not be able to find any answer is, let's say, this case: -10, 8, 3 and 2. Here, no matter what you do, if you are not applying operation on the current guy, if you don't apply operation on the current guy, then that guy will always come at the first position. No matter what you do with these people, they would always be larger than -10, right? And if you apply operation on this guy and it becomes 10, then no matter what you do with the other people, they would always be smaller than 10, right? So if you figure out the number of people who are having smaller absolute value than you, then you can just check out if that count of these smaller people than you is greater than equal to n by 2 or not. Um, or basically, let's find out the exact expression. So if let's say n is odd, then you want to have n by 2 people bigger than a1 and n by 2 people smaller than a1 after applying the operations, right? So for the people who are having the larger absolute value than a1, you can control whether they will go in this range or this range. You can control them very easily. But for the people who are having smaller absolute value than a1, they will all either go into this range or in this range, right? So if let's say the count of those people is C and T, and that C and T is greater than absolute value of n by 2, then it means that no matter what you do, if you have the positive value of a1, then you will have more than n by 2 people on the left hand side, which means that a1 cannot be the middle guy after sorting the array. And if you keep the negative value of a1, in that case, you will have more people on the bigger side. So again, a1 cannot become the median. So our solution here in this case will be a straight away no, right? In case if the count is greater, sorry, less than or equal to n by 2, then what you can do is all of these people who are having smaller absolute value than a1 will obviously go into one of these ranges. Let's say all of them, you keep all of them smaller. Then with the people who were having larger absolute value than a1, you can just keep some of them with negative values, so that you will have exactly n by 2 number of people smaller than a1 and exactly n by 2 people greater than a1, right? So if this condition is true, then your answer is always yes. Guys, is it making sense? I actually explained the thought process, the way in which I had come up to the conclusion, like how I had realized how we can solve the problem. So please tell me if it also look helpful or not. If you feel that when I explain my intuitions and the thought process, things become too cluttered, then please tell me straight away. I will stick more with the solution and will tell you less about the thought process. So please come. Okay, B and C, where so mainstream problem. Yeah, B and C are gonna be the main problems for this PCD. MX, MN, and MX, MN. I don't know what is this condition you're talking about. Then expression. Is free from the pre to inverse. Guys, please don't talk about problem C. Please tell me about the problem B for now. Give some guidance for DP problems. I would recommend you to go to Striver's A to Z sheet and then CSES DP section and then the add coder DP contest. You can search about all of these things online. You will get to know about these. solve problems there, you would be good to go with DP. Okay, so for now, we have understood how our solution will look like, and we can just code it up. Oh, no, no. There is one more case that we have to discuss. That is, what if n is even? In case if n is even, then you would want to have n by 2 people smaller than a1, or actually n by 2 minus 1 number of people smaller than a1, and n by 2 people greater than a1, right? If let's say you were having 4 elements, then you would like to have your a1 sit at this left middle position after sorting the array. So you would like to have n by 2 minus 1 number of people smaller than a1 and n by 2 number of people greater than a1, right? So if let's say count is the number of people who are having um, smaller absolute value than a1, in that case, you would like to have all of the people who are having smaller absolute value than a1 in this range, because this is the bigger range, right? Like if you keep a positive value of a1, if you keep a1 as positive, then in that case, all of these count number of people will come on the left hand side of a1, which is having less number of slots. Whereas if you keep a1 as negative, then you will have all of these people who are smaller than a1 in terms of absolute value would actually be greater than a1. है ना? All of these people would be greater than a negative value of a1. So you would like to have all of them being greater than a1 because you have more slots here. You have n by 2 slots here. So in a nutshell, if count this thing is smaller than or equal to n by 2, then also you can always have your answer yes. You can always um, apply operations in such a way that all of these people would be on the right hand side, and um, like the rest part would be just like the same way as we had done for the odd value of n. And in case if n is greater than n by 2, then answer is obviously no. So we just have to implement it. It is a very simple thing. You can just run a for loop over this array to find out the number of elements that are having smaller absolute value than um, a1. Just find out the number of people having smaller absolute value than a1, and after that compare this count with n by 2. For even number you have n by 2, and for odd numbers you have floor of n by 2. So you can just always talk about floor of n by 2, that this count should be less than this, and it's good to go. Let me show you the code. For the A problem, I don't remember if I had shown this code or not, but it is just a single one-liner. As for the B problem, the code is very simple for B problem also. We will first of all take all the inputs. Then for the part of finding out the number of people who are having smaller absolute values, we can do it. Like let me just rewrite the code. During the contest, the code that I had written is a little more complex than the one that I'm about to write here. Um, Count should be incremented if absolute value of AI is smaller than absolute value of A0. Yeah. And if at the end of the day, if this count is smaller than or equal to n by 2, then the answer is yes, else the answer is no. Or you can write it in this way, count being less than equal to n by 2. Now your code will look like this. It's a short code. So we are taking the inputs, then we are finding out the number of people who are having a smaller absolute value than A0, and then we have been just writing the answer that count should be smaller than or equal to n by 2. I hope this is clear. Please tell me in the chat how to increase typing speed. Obviously, just practice. I'm not getting clarity. Um, can you please point out a little bit, like the exact case where you're not getting the clarity? Maybe I will just do a recap, and then you can mention the place where you felt things are a bit off. So let me repeat the problem again. In the B problem, we were being given an array A having n number of elements, and can be pretty huge. We are permitted to apply a type of operation as many times as we want. In the operation, we choose an integer I, and we just multiply the index on the value AI with -1, or basically we set it to the negative of the value. What we want to do is, at the end of the day, A1 should become the median of the array. The way median is defined is, if you have an array, just sort it, and the middle guy you have now is gonna be the median of the array, right? This is how we calculate the median for the odd number of for an array with odd elements. And for an array having even number of elements, instead of taking the average of these two median middle people, we will define the left guy among these two middle people as the median. So this 3 would be the median here if you have uh, these 6 elements. Then we had covered a few sample test cases, like if you had an array like 1 2 3 4 5 and you wanted 1 to become the median, then you could have just set two of the people who are greater than 1 um, as smaller than 1 by applying operation on them. So 1 will become a median. In the second example, we had 4 2 0 and -5. So here we did realize one thing. If there are some elements which are smaller than 4, if there are some elements that are smaller than the first guy, and you keep the value of the first guy as positive, then all the people who were having smaller absolute value will always come on the left hand side in the sorted array. If you keep a negative value for 4, then you will have these people always come on the right hand side. So this is something that we realized there. So for making sure that 4 becomes the median here, what we did is we made 4 to -4, so that these guys will be larger than 4 and this guy is already smaller. So we don't really need to apply an operation here. And from there on, we did conclude that we need to find out the number of elements that are having smaller absolute value than the absolute value of A1. Because for those people, we can't really do anything. We can't do much there. And for the other people who are having a greater absolute value than A1, we can decide whether they should be on the left hand side or right hand side according to our choice by applying operation on some elements and not applying operation on some elements as we wish. So I took an example where we will never be able to find out, like we will never be able to make the first guy median, because here all the people are smaller than the first guy. So if you just don't apply operation on this guy, then all the other people would be greater than -10. No matter whether you apply operation on these people or not, they will always remain greater than -10. Nextly, if you apply operation on -10, then no matter whether you apply operation on these people or not, they will always be smaller than 10. Right. So here I formulated the thing a little bit, that let's say count is the number of people who are having smaller absolute value than A1. Then if this count is greater than n by 2, then in that case, at one of the sites, you will definitely have this many people who would be greater than or smaller than the current guy. So you will never be able to achieve this thing, that there are n by 2 smaller people than A1 and n by 2 larger people than A1. This thing would be unachievable. So to achieve it, you need to have count being less than equal to n by 2. In that case, you will return yes. Otherwise, no. And then I did cover the case for n being even. When n is even, um, you will have two middle people on one side. On the larger side, you will have n by 2 people. On the left hand side, you will have n by 2 -1 number of people. So the only change here is we are a little bit more specific, that since the number of slots on the right hand side are more, we would like to have a negative value of A1. Like we will apply an operation on A1 if required and make it negative, so that you will have, you can have n by 2 number of people greater than A1. And among these n by 2 people, you will definitely have count number of people greater than A1. So in case if count is greater than n by 2, then you cannot have um, a1 as the median in any possible case. Like there is no possible case. And in case if count is less than equal to n by 2, then you can just make a1 the median in the same way as we were doing this for the odd number of elements. So this is the recap for the B problem. Move to C, please. See, I also want to move to C. So guys, just please confirm if it is clear now or not. If count is 2 and n equal to 4, how answer B? Yes. Okay, let me take the case. Uh, in this example, count would be 2 because there are two people who are smaller than having smaller absolute value than a1. So you can have both of them on the right hand side. A1 is here. And for the people who are having greater absolute value than absolute value of a1, you can just place them as per your convenience. So here is an example where you are having a1 as the median and count is 4, sorry, count is 2, n is 4. Is it clear? Okay, great. Okay, so if we are done with the B problem, then now let's move on to the C problem. This is going to be the most complicated problem for this PCD. Okay, so before starting the C problem, I would like to have a 2 minutes break just to give rest to my throat so that it would be easier for me to speak. Okay, I'm back. But what should be the expected rating if you are able to consistently solve till div 2C? If you are consistently able to solve ABC and a div 2 contest, then you will soon become a specialist. And if you are able to solve ABC fast, then you can reach to 1600, 1700, and even 1800 rating. If you are lucky, like in case if you are solving ABC quickly and the D problem is too difficult, so less people are solving D problem. In those scenarios, you can reach till 1800 rating, 1900 if you're too lucky. है ना? You can aim to become at least an expert before focusing more on the D problem. Just try to solve ABC quickly enough until you reach expert. Can you explain E? No, I did not do the E problem. Since I was not giving it in a rated manner, I was not giving the contest in a rated manner. Um, I did not do E properly. Like I felt that it would probably be difficult enough for me to be unexplainable. Okay, so let me discuss the E problem. It says that we are having n square cards with values from 0 to n minus 1, and there is a grid of n by n size, and we have to place exactly one card in each of the cells. The minimum excluded value MEX of a subgrid is defined as the smallest non-negative integer that does not appear in the subgrid. Our task is to arrange the cards such that the sum of MEX values over all the subgrids is maximized. So basically, you would have a value n, which is like you would be given this value n, which is denoting n by n grid. And you have to fill in values from 0 to n square minus 1 into this grid such that each cell is having exactly one value, of course, and every value is coming exactly once in the grid, so there should be no duplicates. And you want to find out what is the maximum possible, like you have to construct a grid such that the um, sum of MEX of all grids is maximized. You have to make sure this thing happens. Now the number of subgrids, oh sorry, it is subgrid. No? Now the thing that makes the problem complicated for us is that the number of subgrids in the grid can be just too many. There can literally be too many grids. You can have this as a grid, you can have this as a grid, this 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 grid. And there are just too many grids. And right now I only marked all the grids that are starting from here. Just imagine how many grids you will have starting from here, how many grids starting from here, here, here. So there are just way too many grids. So you can't even do a dry run for the sample test cases. Yeah. The sample test cases here are of very small size, 2 and 3. And even for this sample test case of size 3, you can't manually do a dry run. So this is why the problem becomes a little complicated. Otherwise, the problem would have been simple if it had been an subarray or something where you could do the dry run stuff for solving it faster. Okay, so our goal is to just construct a grid such that this thing is maximized. So guys, to make sure the problem statement is clear, I am taking the first example, which is having n equal to 2. So in n equal to 2, what you have to do is you have to construct a 2 by 2 grid such that the values from 0 to n square minus 1, that is the values from 0 to 3, would be placed in the array, something like 0, 1, 2, 3, or so on. And the MEX should be maximized. So the solution in the sample test case is just 0, 1, 2, 3. In this case, there is this one subgrid having MEX1, this subgrid having MEX2, subgrid with MEX1, this subgrid with MEX4. For all the other subgrids which are not having 0, the MEX value is just simply 0. So obviously we don't really need to count all these subgrids, right? So here, yeah, I think there are only these 4 subgrids that will have a non-zero MEX value, and the sum should become 8 here. Enough. So obviously, I think you can already feel the pressure that it is not so easy to figure out where should you place the first zero, then where should you place the one, two, three, and four. And obviously, it is not easy to do all the dry run stuff, like what would be the sum of subgrid MEX over all the subgrids and all, right? But still, let's take out another case. Another thing that you could have done, like another way in which you could have filled it, would have been something like 0, 1, 2, 3. So here the MEX would have been like 1 for this, 1 for this subgrid, 1 for this subgrid, and 4 for this subgrid. So the sum will come out to be 7, right? The only difference in this and this case is you have swapped these two people. The loss that we are getting here is earlier this subgrid was giving us an MEX value of 2, whereas it is giving us an MEX value of 1. So here we are losing. In a nutshell, you can see that this is the best case where you're having 1 coming up right on the side of 0, right? Okay, so till now, my goal was to just make sure that you people have understood the problem statement. It doesn't matter if what I discussed just right now makes any sense or not about having 0 and 1 together. It does not really matter right now. Just tell me, are you guys comfortable with the problem statement of A? Oh, problem statement of C for now? Is it clear? Okay. Okay. I think I need to clarify one thing first. See, this C problem is a constructive problem, right? If you look at the tags of the problem, it is a constructive algorithms problem. Or in other words, this is basically an ad hoc problem. So generally for these problems, um, it is quite common that uh, you might maybe I think, yeah, like let's talk about normal problems. What happens is in a normal problem, you generally have some input from which you decide how the output should look like, and then you match whether your output, like in the input, whatever constraints you had, you create your output while making sure that these constraints are managed, and then you have some output, and then you check if your output is correct or not, right? This is something that generally happens in normal problems. But in constructive algorithm problems or ad hoc problems, one more mindset. There is another mindset for solving these problems, which is probably more efficient in case of ad hoc problems. That is, try to guess some output, like guess this thing, guess some output which is looking good to you, and then check if it is um, like satisfying all the constraints or not. If it is satisfying all the constraints, then try to find out some pattern in the output. Like try to realize that why is this kind of output, the output that you have guessed, why is this kind of output passing up all the constraints for some input? You know, and try to just find out some pattern which, like, with the help of which you can actually generalize that for this kind of input, create this kind of output, and it will pass on all the constraints. So right now, all the discussion I did in this page was just to tell you about the thought process or the way of approaching a problem. So my thought process for normal problems can can generally be like you have some input and I'm keeping track of all the constraints that I have to follow while creating my output. But a lot of times in constructive algorithm problems, it is better to just guess some output and check it out if it is passing the constraints or not, and try to figure out some patterns which are there in the outputs that are passing the constraints. And once you realize the patterns, you can solve the problem. And um, in a lot of problems, like the current problem, the current C problem of this contest, it can save a lot of time because if your guess is correct, like if you guessed a pattern and that is actually passing all the constraints, then instead of spending 30 minutes, you might do the problem in 5 minutes, right? So now let's, yeah, one more thing. How will you guess an output? How will you guess an output? Generally, it will come out on the basis of your gut feeling, or you can call it as intuition, because we would have solved a lot of problems so far in our competitive programming journey. So we might be getting some intuitions that, hey, maybe this kind of pattern can be a possible solution. Or you can just look at the sample test cases. Maybe the problem setter gave you some hint in the sample test cases. Like for the current problem, as soon as I read the problem, I did go on to look at the sample test cases. In the sample test cases, I saw this thing 0, 1, 2, 3. So for now, I will only tell you mainly about the thought process on how did I approach the problem to get to the solution. For the case when n is 2, the output given in the sample test cases was 0, 1, 2, 3. So one thing that I noticed right away after looking at this sample test case was, along with 0, I'm having a 1. Just to make sure that there are, like this thing will make sure that there are more subgrids which are having both 0 and 1. If I had, let's say, placed this 1 at this place, then there will be some subgrids which could have got MEX of 2, but since I've placed 1 at a far location, um, those subgrids will now have MEX equal to 1 and my answer will actually be bad. You know? So to make sure that the sum of MEX over all the subgrids is maximized, you would like to maximize the number of subgrids that are having 0, 1, both of them. So in this case, you will have a subgrid with just 0, a subgrid with 0 and 1, a subgrid with 0, sorry, a subgrid with 0, 2, a subgrid with 0, 1, and a subgrid with all of the elements, right? So one thing that I noticed right away from here, like I'm talking about the pattern part for now. We want to find find out some pattern or create some pattern of ours. So I would like to have 0 and 1 as neighbors. Right. This thing is gonna be beneficial for me. So this is one observation we have made. Nextly, I looked at the second example test case for n equal to 3. It looked something like 0, 1, 2, 3, 4, 5, 6, 7, and 8. So in this case, the first thing that I noticed right away from this solution um, is that 0 is at the center. How is this beneficial for us? If you have 0 at the center, then there will be many subgrids that you will form now. Like there will be maximum number of subgrids that are having 0. On the other hand, if you place 0 at some corner, then there will be a lot of like a lot less number of subgrids having 0, right? And for all the subgrids that does not have 0, the MEX value would definitely be 0. So all of those subgrids are already useless. So this is another thing that we have noticed for our pattern. We want to have 0 in the center. And why just 0? You would like to have 0 and 1 in the center as well, right? Like you can just guess that if you had a subgrid of 4 by 4 size, then in that case, there are 4 cells that are actually at the center. You know, there is no particular center in case of the grids when n is even. So you would like to place 0 at any one of these positions. You know, if n was equal to 4. Now, from the things that we have noticed so far, you want to place 0 at one of the center cells and you want to have 1 as a neighbor. And now tell me one thing. I can place one here, 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 or here. Where should I place it? Obviously, I should place it either here or here, so that there will be more subgrids that are having both 0 and 1, so that the total MEX value, basically the total sum of MEX values of all the subgrids would be more, right? So you would like to place one at one of these positions. This is how our output should look like. Basically, we are creating some pattern and we have got our pattern till this point. Nextly, let's observe this thing more. For two, like as you had this thing in mind that 0 and 1 should be neighbors, you should have 2 as a neighbor also. You know, you should not have 2 at another corner. You, as you wanted to have more number of subgrids having both 0 and 1, you would want to have more number of subgrids which are having 0, 1, and 2 together, right? So that the MEX values for those subgrids would be even larger. So, yep, it gets us to the conclusion that we would like to place 2 at one of these positions so that this is actually connected with them. These are actually the further positions here. You know, if you have diagonal relation, you would like to avoid it. Basically, these positions are closer than the diagonal positions. So you would like to think about these positions first. You know, this was the idea. So I was having I was not very sure about which one would be better for me. Should I have it here or should I have it here? It was a little more difficult for me to decide. Though I was having a good feeling that maybe having two at one of these positions would be better. I relied on the sample test case output that they had taken zero as a neighbor of, sorry, two as a neighbor of zero. So maybe these two positions are good. So I thought that, hey, for now, let's try to think in this direction. Let's decide to have two as a neighbor of zero as well, so that there are like more number of subgrids now which are having 0, 1, and 2 in comparison to if you had placed 2 here. Let's say if you had placed 2 here, then you would have only um, these subgrids with um, all these three people. Whereas now you are having this one subgrid, this subgrid, this subgrid, this subgrid, this subgrid, this subgrid, this subgrid, and so on, right? In case if you had placed 2 here, then again you would have less number of subgrids in comparison to the number of subgrids you are having right now. Can I delete it? Okay. Okay. Yeah. So we would like to place this 2 around these people. Now for the part of where would we like to place the third guy in the pattern, we can see like in the output they had placed this 3 here, and it actually does make sense. If you have any subgrid which is having these 3 people, it will definitely have this cell also, right? All of those subgrids which are having these 3 people, they must include this cell as well. So if you just place a 3 here, then you would always have the MEX as 4. Like you will never have MEX 3, you will always have MEX 4, because all of these people would, like this guy would also be included. So um, like you can think of it in this direction also, that as we wanted to have maximum number of subgrids having the people 0, 1, 2, 3. So if you place this 3 here, it would be just like a lot of subgrids which are having um, all of these 4 people. And obviously, if you had placed this 3 here or here, then you would have less number of subgrids having all these 3 people, because if you, let's say, placed it here, then you must have at least this biggest of a subgrid to have these people included. So this is definitely better to include it here. Then I looked out for where should we place the 4, and I realized they are placing it here so that you will have subgrids like this one and this one. where you are having all elements from 0 to 4. So I decided that, hey, maybe I can have it at this place or at this place. Both of these should be identical, right? Because if you place it here, then you must have at least this big of a subgrid. And obviously, it means that you will have a lot of subgrids which are having all of these people. The same thing will go on if you place it like this at this position. You will have this subgrid, you will have this subgrid, you will have this subgrid, and so on. Whereas if you place the 4 here, then you will have less number of subgrids because this would be the smallest subgrid that you will have to form for having all these 4 people, right? So I just believed in this idea that, hey, let's keep the 4 here. Then for talking about 5, any subgrid which is having at least these 4 people, like all these 5 people from 0 to 4, will always have this element included as well. So this is the best place to have for 5. Then talking about 6, 7, and 8, they had included 6, 7, 8 like this. I had noticed that if even if I like, it does not really matter where I place the 6, because even if it is here, I need to have at least this big of a subgrid which contains all of these people. If I place it here, again I need to have all these people. If I place it here, again I need to have all these people. So basically I can just place 6, 7, 8 here in any order of my choice. Then talking about 9, 10, 11, 12, and so on, I just tried to follow the same pattern as there was, that you would want to have um like 9 being attached to these people as close as possible. Um and like if you place 9 here, then you will have at least this big of a subgrid which contains all of the people from 0 to 9. If you place 9 at any of these places, the subgrid size would be not too big. If you include 9 here, then you need to, like, then only these subgrids which are having all the elements will have all elements from 0 to 9 and bigger. So this is the best place for putting up 9, 10, 11, then 12, 13, 14, 15. I got this kind of a pattern. So please tell me if it is making some sense or not. Um, by the way, here is a disclaimer, like in case, uh, like not in case, but I believe probably most of you would be feeling this to be a little confusing. They might have a confusion that, hey, why did you place 2 here and not here? And for all of these confusions, they will like, to deal with them, what you should do is just try to place them here and then create a grid. And when you create the grid of your choice, find out the number of uh, find out the sum of MEX over all the subgrids. For finding that thing out, you can actually write a small program where you give the grid as input and it will tell you about the sum of MEX over all the subgrids. And once you get the sum of MEX of all the subgrids for your grid that you have created, then check out the MEX of my subgrids. Really enter my grid, and you would be able to see whether your pattern is working or not. In some cases, like some of you might be having some patterns in mind which you think should work and they will work. For some of you, it might not work. So you will have to think more about debugging it. Obviously, this is the part that I cannot do for you. Um, if you're not able, if you're not even putting up efforts at debugging your own code, then you would not be able to solve problems in contests. So this much is something I need to skip for uh, you to do. Okay. Um, Let me see one more thing. Ad hoc. Ad hoc is basically like the constructive algorithm problems. Explain MEX part, please. MEX part. See. Um, MEX for any array or subarray is basically if you have some elements, let's say 0, 1, 3, 5, 4, and you are being asked to find out the MEX of all of these elements, it is the smallest non-negative element that is missing in this range. So here 2 is the smallest element that is not there in this array. So MEX would be equal to 2 here. And um, I just forgot to talk about MEX here because this is something very common for the C problem and above. So I just forgot that for some people this thing might be new. Some might be looking at MEX for the very first time. So I'm sorry about it. And okay, so you asked, but why? But can you please specify, like, for which thing did you ask, but why? Max expert admin specialist. Yeah, that is for um, quickly solving ABC. Used up, down, left, right pattern for this. Yeah, that is my solution also. But why spiral also works here? What is the proof for that? Yeah, I'm about to come to that. Till this point, I have not actually talked about spiral or anything. I only talked about a way in which you would like to put up the elements. Right. Now see, there is a major issue while solving the problem. That is, you have got a grid in your mind, but can you really verify if the grid that you have got in mind will have the maximum possible value of MEX or not? The thing is, you cannot verify this. You cannot verify this mentally. So what I do recommend you to do is write out a C++ or basically a program in any language of your choice, which will take a grid as input, and it will tell you about the number of, it will tell you about the sum of MEX of all subgrids. So that at the very least, when you think about a grid, you would be able to see if it is actually having the sum of MEX big or not, right? Nextly, if you have something in mind that, hey, if I had placed this 4 at this position, or if I had placed this 4 here and 5 here, in some cases it might be possible to prove whether the number of subgrids, whether the value of this thing will change or not. But in some cases, it might not be possible. It might not be possible for you to easily determine whether the value of this thing will increase or decrease. And I think this is the reason why the uh, problem took some, like, it took over 5 minutes for even international masters and grandmasters, even for legendary grandmasters. Some of them took like 5 minutes and bigger and more. And generally, like people at the rating of grandmaster and so solve the problem in within 5 minutes. But I think they took over 10 minutes in general for the for this problem, because it's not really that easy to verify that. Okay, so we have got a pattern. We can't be completely sure whether the solution we will get here is gonna be the best or not. We are not 100% sure whether this thing would be maximized or not. We are not 100% sure. And I cannot think of any good way to get 100% sure about it. All we have done is we just notice the pattern, like we just look at the sample test cases, try to find out some good observations so that we would have a better idea of what kind of um, grid we should create. And we just try to create some patterns. We just find some patterns for ourselves, and then we created a grid while just following the pattern. We did the things that were looking good to us. And there is no guarantee that during a contest you might get this kind of a grade in the first go. You might actually get intuition for some other grade which might fail. Like in case if you had thought about placing 2 here, it would have failed because 2 is good towards the center. If 2 is coming here, then the number of subgrids that will have all 0, 1, and 2 would probably be less than the number of subgrids which have these people here. Right. Now talking about how will you um, print this? How will you print this pattern? Right now this pattern is looking very random. So for that thing, I just try to think of making it a little simpler. So I know that I would definitely place my 0 at the center, right? For the 1, I do know that I will place it right after the 1, right after the 0, right? and that one should also be in the center. Now for the 2 guy, earlier I was placing it here, but after some time of thinking about how can I make the part of printing the pattern easy, obviously the C problem is not supposed to be um, both constructive and implementation heavy. If you have to think about a pattern, then the um, implementation part should be very simple. If in case the logic part is simple, then implementation might be difficult. Both of them should not be difficult at the same time. So um, if even if you just use this much brain, you would have an idea that, or you would have a gut feeling that probably the implementation can be made simpler. So I just try to think, how can I print this pattern? Maybe I can do something like 0, 1, 2, 3, then 4, 5, 6, 7, 8, then 9, 10, 11, 12, 13, 14, 15. I did try to think about different patterns. And eventually I realized that if I place them in like this order, 0, 1, 2, and 3, this is the exact same as putting up them as 0, 1, 2, 3, because any subgrid that is having 0, 1, and 2 will always have 3. Whether I have 0, 1, and 2, uh, whether I have 0, 1, 2 like this, in that case, this guy will always come. Or if I have like this, then in that case also this guy is always coming. So I can have 0, 1, 2, 3 in this way also. And then I just like had the same observation at other places. Like instead of writing 4 5 like this, if I had written 4 5 like this, then also all the subgrids that were having all these 4 6 people will still have these 6 people, all of those subgrids. You know, there will be no subgrid which is having one of these cells and all of these 4 people. So you can be pretty lenient regarding this, like writing 4 5 in this way or 4 5 in this way. So I just realized that hey, even if I write 4 5 like this, it is the same thing, right? Instead of having this subgrid, if I'm having this subgrid, everything is the same. It is basically as if I rotated this array 90-degree. Then talking about 6, 7, 8, whether I place them in this way or I place them in this way, that would be the same, because after this C, after these 6 people, if I want to include even just one single extra guy, then I will have to include all these 3 at the same time, right? So I just realized that hey, I can go like this. And as soon as I noticed this pattern, like I did not even go till this 8 point. I think I had realized this after this 4 wala point, that I can probably go in this point, in this way. So I just I just drew this thing completely, and then I verified that hey, will this actually have the same impact as the grid that I had created earlier? So for all the subgrids that are having 0, they must include this cell. All the subgrids that want to have 0 and 1, they must include these 2 cells. All the subgrids that need to have 1, 0, 1, 2, they must include all of these 4 cells. So they will basically get 0, 1, 2, 3, 4. Then for all the subgrids having 0, 1, 2, 3, 4, they will actually have to include 4 and 5, both of them together. Then it will become like this, then it will become like this, then it will become like this. Right. So I just noticed the spiral pattern, and printing a spiral pattern is something we used to do while learning about loops, right? Or yeah, we used to do it at the time of learning about loops and arrays. So I think everyone can do it. One possible way for doing it, like, is to figure out the start point, go into the right direction, then down, then left, then up, then right, then down, then left. This is one possible way for printing a spiral pattern, and mostly people have done it this way. Another way for printing the spiral pattern is start from an end point, go towards the right, up, left, down, until you reach to a place which is already visited. So instead of going down, now go right, then up, then left, and so on. And up. So you will just go on to the right as long as you can, then up as long as you can, then left as long as you can, then down as long as you can, then again right as long as you can go towards the right, then up, then left. So in my case, I did implement in this way because I feel to be simpler to implement and less error-prone. But it's the same thing even if you implement in this way. Okay. Okay. So what's the feedback? Please explain MEX for 2 into 2 grid. See, if you have a 2 into 2 grid like this one, instead of an array, this is like MEX of this thing would be equivalent to MEX of 0, 1, 2, 3. Exactly. Just put up all of these elements into an array and then find out the MEX of that array. Do it in this way if it looks more convenient. What would be the checker function for this that works in n square? See, checker is not that easy to implement. You can find out the sum of MEX for your array, and you can actually implement it in n raised to the power 4 time complexity also, since you're not gonna be submitting it. But as for the checker, it is not that simple to create because you would like to go over all the possible different um, permutations you can have of this of the grid. So I don't think we can have a checker easily. Can you explain problem E? No, I cannot explain problem E. I have not done it yet. How to implement it? I did discuss a way of implementing it. You need to build this pattern. So either you can go like this, start from an end, from some point, go one step right, one step down, one step left, then go one step left again, then two steps up, or actually maybe like one step right, one step down, two steps left, two steps up, three steps right, three steps down, then four steps left. Like you cannot go four steps left because you don't have any more elements. But if it was a bigger grid, then you would have gone four steps left here, then four steps up, five steps right, five steps down, and so on. And you can create this kind of a thing. Or the simpler way that I feel is start from some point, go in one direction as long as you can, then turn as go as far as you can, then again turn. Whenever you realize that you cannot go further, then just turn. And you need to be good enough to implement this pattern once you have got to know that this pattern will work. In case if you are facing some trouble with implementing the pattern, then it means you need to put up more efforts at your implementation. Um, like this is something very important for you. And sir, if I'm not comfortable with AB, should I try to understand problem C and after contest focus on easier problems? I have a simple rule that I discovered in my journey from CM to master, that um, you can start, like you can observe problems in this way. If you are able to solve the first problem within 60 minutes of the contest, then there is a chance that you can solve A and B problem within 120 minutes of the contest, right? If you can solve AB in within the first 60 minutes, like probably the C problem will take you more time than A plus B combined, you know. So if you cannot solve A and B within 60 minutes of the contest, then there is a very less chance of you being able to solve A plus B plus C within 120 minutes of the contest, right? Similarly, if you can do A plus B plus C within 60 minutes in general, then there is a chance that you can do A plus B plus C plus D within 120 minutes. Obviously, this is uh, gonna be like this will vary because the rating, like the difficulty difference between A and B can sometimes be too big, sometimes it can be small. Sometimes the difference between difficulty of ABC Like B and C can be big enough, sometimes it can be small. Here I think that this time the difficulty difference was good enough between B and C. And between C and D, the difficulty difference was not too big. So in this case, even if you could solve A plus B plus C in like 70 minutes, there is a chance that you could solve A, B, C, D in 110 or 100 minutes. So this is one simple rule that I do recommend. That if you're not able to solve AB within 60 minutes, then first of all, focus on speeding up your, like improving your speed before trying to focus more on solving more difficult problems. Getting cooked in contest. Well, what was the one specific thing that you helped you to climb from um, spot to CM? In my case, I was like timed up till CM very easily, so there was nothing like that. There is one good habit I had at that time. That one good habit was, um, let's say, let's say if I could think only till this point to print a pattern like this one, and I am feeling it difficult to print a pattern like this one, or if I feel that it will have a lot of implementation, a lot of if else cases, and if I make it wrong, then it will be very difficult to debug. I used to spend hours, but I will just do it. If it is doable for me, even if it is difficult, but I know that it is doable, then I will do it for sure. है ना? I will not leave it that, hey, let's just ask someone else to help me do it. So I think that one good habit was actually very helpful for me, because something that you are feeling hard today, let's say you are feeling the C problem as hard today, but you know that this is like the problem is doable for you. It is implementable. Maybe it will take hours, but you can implement it. Then implement it. Today's like it is looking hard. In future, it will look simple. But if you just leave it as it is for now, then it will look hard even in future. And there was one more good habit. If let's say I solved C problem in 50 minutes, and I saw that Jiangli or tourist did solve the problem in 5 or 3 minutes, let's say, then I used to look at their codes. I used to try to think what could have been the uh, idea that they would have got right after reading the problem, and why did I not get the idea directly. All the 50 minutes that I had spent while thinking about the solution, I used to analyze um, the things that I had thought about during these 50 minutes, and I used to figure out the mistakes, like maybe um, you make like you will just when you do this kind of analysis, you will realize there are some common mistakes you make. Maybe like you think about an approach and you then start coding it up, and after 20 minutes of implementation you realize that, hey, this approach is completely incorrect, and you have just wasted all those 20 minutes. So I used to analyze all those mistakes and improve there. So I think that was the good habit which really did help me. Reached people. First of all, try to solve A and B problem within 60 minutes. And after, like in a contest, when you solve A and B, and then obviously you will spend some time at trying to solve the C problem. If you feel that the C problem is upsolvable, and you look at someone else's solution or editorial and realize that, hey, this is actually upsolvable, then upsolve it. In case if you feel that it is very difficult for you to upsolve, then maybe you can skip it for now. And your main focus right now should be to, first of all, being able to solve A and B within a a good time limit, right? Maybe like within first 60 minutes, so that you will have enough time in the contests to try the C problem. If you are solving A and B problem in 90 minutes, then even if you can absolve the C problem, it might not be very beneficial for you, because during the contest you will not have enough time to solve that problem. Okay, so let's look at the code ones, and um, guys, first of all, let's look at the code and then we will move on. I think I should have discussed all of these things after the C problem here. The code is pretty simple. Like in case if at the beginner time when we used to practice problems related to patterns, if you had done enough practice, then it is very simple problem. You can just create a recursive function. I just created a recursive function in which I will um, I will print values of all of these people. I will fill values of all of these people. And then I will call the recursive function for this layer. So let's say if there was a 6x6 grid, then what will happen is, first of all, I will have a recursive function that will fill up all the elements here, and it will call the recursive function for from this point on, which will fill all of these people, and it will call recursively for this, which will fill up all of these people, and so on. So there will be n by 2 number of layers, and I will just fill on the values for all of these layers one by one. For the part of solution, I'm first of all taking the inputs here. Input is just a single integer n. I created a vector of integers, a 2D vector basically, answer, and I called the recursive function where I will pass on the cell, like the row number and column number for the cell, the size of the grid that we have to fill, the current value that I have to fill because I have already filled some values. So like if you have already filled values from 15 to 4, now this layer should have values from 3 to 0, right? So that is why you need to pass on the value. And this is the answer vector which would be filled up. So here is the base case, which I felt, I don't know if it is really necessary or not. But in my base case, I've said that if the cell does not exist within the grid, or if the value of the cell is something not equal to -1, which means that the value has already been given to the current cell. It means that I have already completed the whole spiral path and I can just close the recursion now. Otherwise, I will give the first cell a value and then I will move towards the right, then towards the downside, then towards the left, then I will move towards the upside, and eventually I will reach a place, a cell which has got its value, and now I want to move on to the next layer. So for moving on to the next layer, I'm calling recursion for r c plus 1 and well and answer. Here in this function call in these while loops that you can see, the values of r, c and val would be updated. Now explaining how this is working, I don't think it is really that necessary. If you have good practice, you would be able to understand it right away. If you don't have good practice, then you should not focus on understanding my code. Instead, spend hours at writing your own code because that would be more helpful for you and not really this part of looking at the standard way of coding it up. By the way, just to tell you what is happening here is when I'm moving towards the right, what I'm checking is the next, the right, there should be a cell on the right hand side, and the cell on the right hand side should not have got any value yet, because if it has already got a value, then it means that maybe I am trying to go outside the um, current layer. So in those scenarios, I will just stop. Otherwise, I will move on to the next cell first, and then I will give it a value, and that's it. My code might actually look a little complicated to some people because I um, have written the plus plus r plus plus c val minus minus all of those things in just one line so that my code becomes concise. Um, Basically, I like that thing. Okay, so now we are done with the first three problems. Only one problem is left. I can look at your doubts here. Sir, placement season is coming. I have done a good amount of DSA, but not have done dev. Please guide me on that. In that case, I would recommend you to focus more on the dev part for now, at least till the placement season, until you're confident that you have good projects. Because the time, the opportunity that you're getting right now for the placement season is something you will not get for a long time after that. Like if the placement season in is gonna start after maybe like 2 months, you will have a lot of opportunities at that time after the 2 months time. But if you miss out that opportunity, then for the rest of the year you will have very less number of opportunities, and you will not have those good opportunities anymore. Like Google will hire only once, Microsoft will hire only once. So for all these companies, you will not get more opportunities. And what was my strategy to reach master? To be honest, I was not really having any strategy. I should have become a master around 1.5 years ago. But at that time, I just got a few minus, like I got a few bad contests in a row, and I was getting good contests as well at that time. Basically, good contests, bad contests, and so on. So if I had kept on giving contests, then I would have become a master. But I just lost um, my interest in CP, and my exams were also coming. So I stopped CP at that time. And then it took me quite a long, like, I tried to come back a few times, but both of the times I could not really give on contest for a long time and had to just give up again and again. And then I just started competitive programming once again a few weeks ago, and that time it worked out. In which year? Right now I'm in fourth year, so it doesn't really matter. So for now, guys, let's have a 2 minute break. After the 2 minute break, we will start the D problem. I think the D problem would be a little simpler to explain in comparison to the C problem. So yeah, we will meet in 2 minutes. Okay, I'm back. Is this the idea of mud sort? Is the idea of mud sort in D famous? I don't think mud sort would be used to. In my case, I did not use mud sort. Oh yeah, we don't really need mud sort. It's not gonna be used in Illinois. I don't think anyone would have used it. You were asking for mud sort, no? Yeah, mud sort is not used. So the D problem says We are being given a permutation A of length n. We are allowed to apply the operation any number of times, possibly zero. What we have to do in the operation is choose some I index, then swap AI with A of I plus 2 and AI plus 1 with A of I plus 3. In other words, if the permutation looks like this right now, A1, AI plus 1, AI plus 2, AI plus 3, it would be permuted to AI plus 2, AI plus 3, AI plus 1. We have to determine the lexicographically smallest possible permutation that can be obtained after applying the above operation any number of times. Yep. So this is the question. We are being given a permutation A of size n. Let's say the permutation is 5, 4, 3, 1, 2. What we are allowed to do, the operation that we are allowed to do is choose some I, then swap AI with AI plus 2 and swap AI plus 1 with plus 3. That's it. Just do this much. And we want to find out the lexicographically smallest possible arrangement of A after applying the operation. After applying above operation any number of times. You got the idea, I think. So we can apply the above operation any number of times, and we want to obtain the lexicographically smallest arrangement of A. The problem is pretty straightforward. The value of n here can be as large as 2 into 10 raised to the power 5. Right. So, okay, there is one thing that I think I need to do. Guys, please confirm if the voice is coming better now or was it coming better before? I think my voice starts cracking a little bit and it should get better now. You can give me the feedback later on. Okay, so please confirm it once now. Maybe I cover everything and then I realize that it's not coming good. That would be bad. Is there anyone right now watching the video or not? I forgot. I can also watch. I also have a mobile. Oops. Yes. Okay, it's coming good. Yeah. So for this problem, all we have to do is we have to we have to find out the smallest lexicographical or lexicographically smallest arrangement of this array A after applying the operation. So one thing that I want you people to notice is in the operation, since we are swapping AI with AI plus 1 and AI plus 1 with AI plus 3, AI, right? We are swapping these people. So if in an array, let's say these are all the even indices, you know, these people are having the index even, and these people are having the index odd. So if there is an element on an odd index, after applying the operation, it will still always remain on an odd index. And if there is some element which is on an even index, no matter how many times or in how, like in which way you apply the operation, it will always remain on an even index, um, basically on some even index, right? This is one observation here. In case if you had not seen this thing, then please stop the video and um, try to solve it now. This is a very important observation, which will probably help you to solve most of the problem. Nextly, the idea is, let's say if you have two permutations, A and B of n integers, all integers from 1 to n. The first permutation A is having the first element 1, and the permutation B is having the first element is, let's say, 3. Does it really matter what comes here and here for deciding which one is lexicographically smaller? No. A would always be lexicographically smaller than B if the first character is, if the first integer is different, right? Now, since we want to find out the lexicographically minimum arrangement of some array, can I say that we would like to use the operation in such a way that whatever guy is, like whatever is the minimum of these four people, that guy should reach the first position, right? I can, because if that thing is possible and I am not doing it, then I will never be able to find out the lexicographically minimum array A. So first step that I want to do right now is, for all the elements that are on even index, you want to find out the minimum one of them and apply operation in some way so that the guy comes up at the front. So if you take out the example that we had earlier, 5, 4, 3, 1, 2. Here for the even indices, the minimum guy is 2. So you need to apply operation in such a way that 2 should come at the front, right? Now, in which way we will apply the operation, it can vary. You can have multiple ways of applying the operation to bring out this guy from the back to the front, because you will be able to swap only these two, then these two, then these two. While making a swap between these two, you will have to either make a swap between these two or you will have to make a swap between these two, because the operation allows us to swap people in pairs. So there can be multiple different configurations that we can reach when we are making sure that 2 comes up at the front. But for now, for simplicity, let's not worry about it. Let's only worry about the fact that 2 will reach the front, right? In some way. We don't know how the array will look like, because it will depend upon the number of, like the way in which we have applied the operation. Now the next thing is, can I say that the same thing, like the same reason for which I brought the 2 at the first position, I should bring the smallest guy of these two at this position with the same reason? Because if I place a bigger guy here, then it would definitely be worse than the permutation starting with 2, 1. So I need to bring this 1 here, right? Now, once I've brought the 1 here, I would like to bring the smallest guy at, among these two at this position. But there is a catch. Right now, here is a catch. The thing is, if right now the array looks like, just imagine if the array right now looks like 5, 4, 3, I can't really swap these two now because I have only 3 people left. I don't want to apply any operation in which these people are affected, and with just these 3 people, I cannot make an operation, right? So at the end of the day, you might have this one pair where people are at each other's position, like 3 should have been here and 5 should have had been here, you might have this one casualty. Everything else would be good. है ना? Your whole array from the front till the last fourth position would be sorted, or at least sorted in the basis of all even people being sorted here. Like if you have an array like this one, let's say, maybe I can have this. Let's say you're having a very big array like this one. Oops, I missed it again. Yeah, मैं क्या कर रहा हूँ? Yeah. Okay. Okay. So let's say this is an array that we have to fill. You know that you would like to put up the smallest of all of these people that I have marked with the blue line at this first position. Then the smallest of the people with the yellow, sorry, not yellow, but orange indices on this guy. Then the smallest of these people remaining should be placed here. Then the smallest of the other orange at this place. Then the smallest of all cyan on here, and so on. So guys, can I say that I'm pretty much just gonna be placing the um, I will just pretty much um, place all of these cyan people, cyan indexed elements on these indices in a sorted order, right? Because I'm picking the smallest guy here, then the smallest guy of all of these people here, then the smallest guy of all of these people here, then smallest of all of these at this position, then smallest of all of these here, then smallest of all of these here, and obviously there is just one guy left, so it is also the smallest of the remaining guys. So this would be completely sorted. Talking about all of these people, they would also be sorted till this position. For these two, only for these two positions, they might be unsorted. Does it make sense? What's happening is going on. Really feel you don't really need to get demotivated after a contest, because if you are learning something new from a contest, then you are at least gaining something, right? You could not solve a problem during the contest, so you got a problem from which you can absorb and learn something new. So you are either learning something or you are gaining rating. Okay, let's talk about this now. So what we have realized so far is um for any given array like 4, 5, 4, 3, 1, 2, you can easily tell that either the final answer will look something like um you had these pairs here. Yeah. So either it would look something like 2, 1, 3, 4, 5, or it would look like 2, 1, 5, 4, 3. Right. Basically, if you just sort these people together, then it will be 2, 3, 5. And if you sort these together, then it would be 1, 4. So either odd and even indices would be sorted properly, or they would be sorted, but the last and last third guy would be swapped with each other. So one of these would be the final answer. We just need to find out a way in which by just looking at the array, we should be able to figure out whether the final answer would be like this or would it be like this. है ना? One possible way to solve it right now is to just um, simulate the whole process. You want to bring the smallest guy here, apply operations to bring it to the front, then apply operations to bring the smallest of these indices to the front, and so on. In that way, you would either be left up with this, like you would either be left up with this array or this array, and you can decide your answer. but that will have a big of n square time complexity, which is not so optimized. So we would like to find out some way in which we can decide whether we have this answer or this answer. In my case, I did spend a few minutes or maybe even like 10 minutes or so to figure out a way in which I can find out the answer. And yep, I did notice one thing. If you have a permutation, let's say a permutation here is 5, 3, 2, and you are allowed to swap any two adjacent elements, है ना? And you want to make it sorted. So either you can make it sorted in odd number of operations, or you can make it sorted in even number of operations. Like right now, I can sort it by swapping these two first, so that it becomes 5, 2, 3. Then I can swap these two, so that it becomes 2, 5, 3. Then I can swap these two, so that it becomes 2, 3, 5. It took me three operations, 1, 2, and 3. Right. So I'm making a claim here. You guys can try to confirm it by by attempting to prove it wrong. You will always need to make odd number of operations for making it sorted. है ना? If after sorting it, if you make one more operation, then it will become unsorted. For keeping it as a sorted array, you need to have exactly odd number of operations. You can never have it sorted in even number of operations. So the lexicographically smallest array that you can obtain in even number of operations is 253, which is basically the whole array sorted and then swap the last two people, which is very similar to how our case would look like, because here we are just swapping these two people after sorting the array. In my case, something is not matching up. So what I did is, for the even indices, I found out the parity, like whether I need even number of operations to sort it or odd number of operations. I called this thing as even parity, like the parity of the for the even indices. Similarly, for the odd indices, the elements on the odd indices, I calculated their parity, whether they need even number of operations or they need odd number of operations to get sorted. If I want to make them sorted after using this operation, you see here the normal operation which I have is basically gonna apply one swap between even indexed elements and one swap between odd indexed elements, right? So if the parities for these people on the even indices and the people on the odd indices is same, then it should be possible to sort all the odd, like all the odd indexed elements and all the even indexed elements at the same time. Otherwise, it would not be possible to sort all of them together, like all odd indexed and all even indexed. So in that case, I will just um, have an array like this one, where the last and last three people are swapped with each other from a sorted array. Now for the part of calculating the parity, like uh, how to figure out whether I need even number of operations or odd number of operations to sort an array. I just took it in this way. Whatever array I have, let's say 1, 2, 3, 4, 5, 6, 7. Let's say it is an array like this one, and I have to sort it. I want to bring the one to the front. So how many people are there which are greater than one here? There are three people who are greater than one. So obviously I will need to apply three operations here to get one to the first position. After that, one would be at the front. Now for the two, how many people are there who are greater than two and are there in front of him? There are 1, 2, 3, and 4. Four people. So I will have to make four more operations to get four at the to get two at the front. You know, then for 3, 4, 5, and so on. I can just find out the number of number of operations required to sort it. You know, I'm just finding the number of operations to sort it. I don't really necessarily need to find out the minimum number of operations to sort it, because if the number of operations after which I can sort it is odd, then I can always sort it in odd number of operations only. So the parity would be odd in that case. I can decide whether the parity is odd or even in this uh, way. And for finding out the number of inversions, okay, now I get it why someone was talking about merge sort. Basically, the number of operations I need to make it sorted here, the procedure in which I have calculated it is nothing but the number of inversions, right? I'm only counting the number of inversions here. For every element, I'm asking how many people who are greater than this number are there before this number. So it is nothing but the number of inversions in the array. You can just check whether this thing is odd or even. And for finding out the number of inversions, one possible way to do it is using the merge sort, as someone was saying in the comment section. This is the gonna be the fastest way. Uh, Another way is by using a segment tree, and you don't really need to do the um, coordinate compression here. So just using segment trees would be enough for finding out the number of inversions. Another possible way is to use the PBDS data structure, as people say PBDS, or basically ordered set. You can use the ordered set data structure. All of these have the time complexity of big of n log n for an array of size n to calculate the number of inversions in the array. It has the least, like this one has the least constant factor. Segment trees would be a little slower, and PBDS would be the slowest one here. Um, and by the way, PBDS would be the easiest one to implement. Segment trees would be the second easiest, or actually maybe merge sort would be the second easiest, and segment trees might be the more difficult one. But it is very flexible. So right now I'm just telling you about the comparison of these things. You should be able to figure out which one is, like, if you have multiple approaches for doing a task, which one is better in which cases. So if you have a template of segment trees and you have done this kind of thing once before also, then I do recommend you to use segment trees, because it is very flexible. Even if instead of finding the number of inversions, you have to find some more information, you can do all of that with just the, almost the same code that you have to use for number of inversions. As for merge sort, you can actually have its template ready, so that you can just copy paste the template to find out the number of inversions. And this is the most beginner friendly way also, because this is something being taught to people at the beginning stage. Nextly, talking about ordered set, if you have ordered set being set up in your local system, then just you can use it. The code for ordered set would be the shortest one among these three, and it is easy to understand also, but it would be little slower than the others. Okay, so now we have actually realized what we want to do. You had been given the array A of size n. Just find out the elements on the odd indices, find out the number of find out all the elements on the even indices, sort this thing, sort this thing, or before sorting it, find parity, find parity of the number of inversions, or basically just find the number of inversions, find parity for this guy also, then sort them. And after sorting them, you can create your answer array, because in your answer array, at the first position, it would be the first element um, of this even array. At this position, it would be the first element of this odd array. At this position, it would be the second element of the even array, then second element of odd array, then third element of even array, and so on. And so in that way, you can create this answer vector. And in case if the parities of odd and even were different, then you can swap the last guy with the last third guy, and that would be your answer. So, guys, is it looking good? Yep, exactly. Your approach is also the same. So let me show you my code here. I copy pasted my template for segment trees. After that, for every test case, after taking the inputs here, I created two vectors, odd and even, in which I have inserted the elements of odd indices and even indices. I created a function within find parity, which will tell us about the parity of the number of inversions. So I'm calculating the number of inversions here. Um, you can see the way in which you can calculate the number of inversions as we had discussed earlier. For every element, you just want to find out the number of people on the left hand side which are greater than you. So I created a segment tree with all values being zero initially. And whenever I find out a value, so like for every I just set vi on the position vi in the segment tree as 1. So I can just query how many people are true in the range from vi plus 1 to n in the segment tree to find out the number of people who are greater than the current guy and they have appeared or they have already appeared. And then I'm returning the parity here. So I stored the odd parity, even parity, then I sorted the arrays, then I filled my answer array, and then if the parities are not same, then swap the last and the last third guy, and then print the answer. That's it. The code for the D problem is actually pretty simple. Um, like sometimes at the D position, you can have more complicated codes, even with this much logic involved. Okay, so guys, do you have any doubts or shall we end the stream? The stream has been 2 hours long today as well. No, it's actually longer than 2 hours. How you managed to speak for so long? Um, I'm not good at it. My throat just starts to have pain. Nowadays, I have actually started to drink water after every one or two problems. Like I discussed the first two problems, then drink water in the like when I take the break of 2 minutes, I drink water and give my throat rest for 2 minutes. Then discuss a problem, then again drink water, then just keep on doing it. So I'm having better results than before. But I also need to see for a better solution. Like um, I think honey can help us. Honey and I forgot the name. Full name. Mulati, I think. Yeah, mulati. People say that mulati is good for us for the soul. So how to properly extract the learning from a question? For example, if someone does a course, some people are able to reach maybe 1600 CF, but some get stuck at 12, 1300. Um, See, to be honest, in my opinion, um, when you solve a problem to get the maximum benefit from it, one thing that you can do is right after solving the problem, or maybe after a day or 2 days or a week, as you feel convenient, come back to the same problem again and try to solve it again. You know? And this time you already know about the solution and you already know about the mistakes that you had made earlier. So if you again make the same mistake, then you would know that hey, um, I had already made the same mistake earlier someday. So like you can just mark this down somewhere that I should not make this mistake. Maybe make a mental note or maybe point it out somewhere, and eventually you will make less and less number of mistakes in this way. And you will actually get to learn about many things also. Like um, when you're doing the same problem after a week, now this time um, Like just try to approach the problem in the same way as you would approach a problem if you see during a contest and you are solving it for the first time. Then in that case, you will even notice the mistakes that you are about to make if you go in the natural way while solving a problem. And basically, you can have a lot of learning. You will, like, I'm not able to explain it too well by just words, but if I take an example someday in a live stream, I don't think it will happen on TLE, but maybe on my channel. If I'm doing a live stream someday, then I will show it. Key, if I'm solving a problem for the first time, then these would be my thoughts. But since I know about the solution, I know these thoughts are good and these thoughts are bad. So I will start making mental notes for me that I should focus on these areas, should not focus on these areas, and so on. Let me show you a dry run for these examples, as you said. Um, so for the case where you have 4 3, no, not 4 3, but 3 4 1 2. You can just choose these two, like you can just swap these two, and these two would be swapped, these two would be swapped, and the array will become 1 2 3 4, which is sorted, so you can't have anything better. In case if the array looked like 3 2 1 4, then the number of inversions here would be one inversion here, that is odd number of inversions, but zero inversions here, that is even number of inversions. है ना? Parities are different, so you can see whatever you do, whatever you try to do, any type of operation. To be honest, you have only one type of operation here, which will lead to something like this, right? 1 4 coming to the front and 2 3 2 coming later on. So this is nothing but 1 2 3 4, in which 2 and 4 are sorted, like 2 and 4 are swapped. So our solution is matching here as well. Then there was a test case 5 4 3 1 2. You can swap these two to get 5 1 2 4 3. Maybe swap these two to bring to the front, two to the front, because our goal was to bring two to the front at from the beginning. So the array will look like this. Two is at the front. Now you want to bring one at the best position where it can come. So swap like this. You will have your array 1 2 1 3 4 5. Now for these three last elements, you can't do anything, even if you want, really nothing. Nextly, the last test case 10 9 8 7 6 5 4 3 2 1. So here the people who are having the even indices are marked with red, others are marked with orange. You would like to bring the smallest of the red at the front, so two should come at the front. Now, obviously, if I show you the dry run by applying two operations here, it will just take too much time. Um, but I hope you got the idea. You can maybe like swap these people like this. When you would have got two here, one here, four here, three here, then maybe swap two with six, five with one, or something, anything you like. 2 1 6 5. Then you will again make swaps and so on until you get two at the front. And coincidentally, one might also come at the front if you had applied operations in this way only. But even if it is not at the front, you can just keep on applying the operations in the same way to bring one at the front, then bring the second smallest guy, that is 4, to the front, then the second smallest of the orange, that is 3, to the front, and so on. So you will have something like 2 1, um, 4 3 6 5, and then 8. And then for the last three people, that is 7 9 and 10 left, you know that you will have a 10 here. As for these two positions, you might have them as 9 7 and or 7 9, depending upon the parity of the even elements and the odd elements. So here in this case, the number of inversions of the odd and the number of inversions of the even indices and all would come out to be the same. So the parities would also be the same. And if the parities are same, then these would be sorted. So it would look like this. Is it good enough? Um, Akshat, is parity the modulo of the sum or only the sum? It's the modulo. Modulo. If I require 7 number of operations to sort an array, and if there is some other operation that requires 30 number of operations, since the parities are same, I can make both of them sorted at the same time while applying the operations. Because once one array is sorted, I can just apply some operations that will waste, and I can just apply two operations that will unsort and sort, unsort and then sort, so that uh, at 9, then 11, then 13, at the end of all these number of operations, the array would be sorted, which could be sorted in 7 operations. So I mean, you got the idea, no? Like if you have an array 1, 2, 3, 4 that is already sorted in 0 number of operations, you can just make a swap here and then again a swap here to make it sorted in 2 number of operations. Similarly, 4 operations, 6 operations, and so on. You can keep it sorted after all of this number of operations, but you cannot make it sorted after 1 number of operations. Oh my god. I was explaining here, but my screen was not shared. My screen was shared here. Okay, so what I've explained here is, okay, guys, can you please tell me? Yeah, during the dry run, I had shared my screen, right? Till this point, my screen was shared, no? Till this point. I, on, I only told about this point without sharing the screen. That if there are two arrays, one of them can be sorted in 7 operations, let's say, and another one requires 13 operations here, then you can just make sure that after sorting it, you are wasting some operations so that even after 13 operations, this first array is sorted. You can keep on doing it like somewhat like this. So at the end of the day, you would be able to make both of these arrays sorted after odd number of operations. Thus, everything would be sorted. Your channel link, I can't share the channel link right now, but I do reply to the comments, so you can just check out my channel from there on if you want. But I don't post much content yet, like currently. I might start posting content in future. Okay, question practice कहाँ से करते हो? I don't practice questions currently. Like I used to practice when I was in my first, not first, but second and at the beginning of third year. So at that time, I used to like look at maybe CACS problem set or some random problems on Codeforces or the problems from the previous contest on Codeforces, the Code Chef. Basically, just do all the resources you can see. That's what my mentality was. जो दिखे कर लो. If I feel that I'm not able to solve DP problems, or if I'm struggling at DP problems, then practice problems related to DP, the standard problems related to DP. If someday I see the EDU section of Codeforces, then just start practicing problems in the EDU section there. Please start discussing in reverse order. Shanvi, actually that is not possible. The problem is if we start discussing in the reverse order, then it might not really look good from the perspective of the user who is watching the recording. And you see, for the one who is watching the recording, whether I have the sorted order or in the reverse order, both of these are the same for him. So, and since our mostly audience is gonna be watching in the recorded order, so I think sorted is better. I have 2 months remaining for placement. Will it be wise to give virtual contest really? Or should I focus on CP31 sheet? Am I kind of done with TSA prep? Um, See, if you ask me, practicing problems of a specific rating is not something I generally do. I used to do this thing for a small portion of time at the beginning of my competitive programming journey. After that, the only times when I did problems specific to some rating is only to get more motivation. Like when did my comeback a few weeks ago. I opened the CP31 sheet and practiced the problems of 800 and 900 related. I knew I would be able to solve all of them within like 2-3 minutes or so. So the main point behind practicing problems there was to get used to all the easy problems, basically to how the easy problems looks like, and nextly to gain more confidence. You should have a feeling like मैं ही जो हूँ, or you can basically get motivated here that hey, I can do better in contests. So like that is the only place where I have preferred to practice problems as per the rating. Otherwise, my personal preference in general is to practice problems from the previous contest. Maybe like open a contest from 2 months ago and start giving it as if you are giving a normal contest. है ना? So in that way, you will have practice for easy problems as well and the hard problems as well. And you will be practicing problems um, against the clock. You will, if you are giving a virtual contest, you will have a leaderboard as well, which will give you a lot of motivation to perform better, which I don't see when I'm just practicing random problems with no timer. So these are a few suggestions from my experience. Baki, it might be different for your case. You can do whatever suits you best. Anything else, guys? Okay, great. Okay, so maybe we can end the stream. Yeah, good night. I'm also tired. Yeah, so bye, guys.